All right, in this video, we're going to talk about mole ratios and simple stoichiometry. So before we can really do problems with this, we have to understand what a mole ratio is going to do. So what a mole ratio allows us to do is convert from one substance to another. Essentially, what that does is it allows me to figure out how much of a given reactant I might need to make a certain amount of product, or how much product I can make from a given amount of reactant. So when I look at this equation here, what this means is that 2 moles of sodium will react with 1 mole of chlorine to produce 2 moles of sodium chloride. So the coefficients tell us how many moles of each substance are reacting or being formed. So let's look at a sample problem. How many moles of sodium chloride can be produced by fully reacting 2.7 moles of chlorine? Now I know from this balanced equation that for every 1 mole of chlorine, I produce 2 moles of sodium chloride. So I can set up a mole ratio problem like this. This is what I'm given, this is what I want. So I can start by writing what I'm given, which is 2.7 moles of chlorine, and I want to find moles of sodium chloride. So I take moles of chlorine and move it down. And I can put moles of whatever other substance I'm interested in on the top. To get the numbers for this, I'm going to use the coefficients from the balanced equation. So for sodium chloride, that would be 2. For chlorine, that would be 1. Remember, if we don't see a coefficient, that means the coefficient is 1. So 2 times 2.7 divided by 1 gives me 5.4 moles of sodium chloride. And logically, this makes sense, right? For every 1 mole of chlorine, I produce 2 moles of sodium chloride. So I should get twice as much as I started with. Let's look at another problem that probably isn't quite as easy to do just in your head. All right, so this equation is the same equation we did in Lab 6.2, the reaction of aluminum and copper 2 chloride to produce aluminum chloride and copper. So this says how many moles of aluminum are needed to produce 6.8 moles of copper. So in this case, we're starting with a reactant. We're saying we want to get a specific amount of copper, so we want to know how many moles of aluminum we have to use. So I'm going to start by writing what I'm given, which is 6.8 moles of copper, and then I'm going to write where I'm going. Moles of aluminum. Remember, to get from moles of one substance to moles of another, you're going to use the mole ratio. So I put moles of copper on the bottom, because I always take what's on the top and move it down, and put moles of aluminum here. So now, where am I going to get the numbers for this? From the balanced equation for aluminum and copper. So I have 2 moles of aluminum for every 3 moles of copper. So on my calculator, put it where you can see it, I would do 6.8 times 2 divided by 3. And I would get 4.5. I'm rounding to 2 sig figs because that's what I started with. 4.5 moles of aluminum would be required to produce 6.8 moles of copper. All right, the next video is going to show you how to do problems with 2 and 3 steps for stoichiometry, so check that out once you feel comfortable with mole ratio.